Okay, so here we have all the parts for building a Bluetooth Super Nintendo controller for Android. And this build isn't going to be nothing's going to be internalized into the controller. I'm going to leave the wire. It's just going to be the external setup, and if you want to put it into a controller, it's certainly possible from this setup to do it. You'll just need to cut down the wires, solder it together real nice and tight and clean, and get it all inside the controller. There's not a whole lot of space in there, but it's definitely possible. I've done it before. Here's the one I had for my senior design project. I had a battery pack put onto it just so I could swap out batteries. I built another one since then that used lithium ion. It was a lot harder to fit everything in, but it's certainly possible. So yeah, I just have a Super Nintendo controller. This is an MD-Fly Bluetooth module. It's pretty basic compared to the Blue Smurf. You can also use a Blue Smurf one though from SparkFun. This one's a lot cheaper though. Ignore the LCD, it's just bolted onto the board. The Arduino Uno. This is a central component. I think this is the 18 mega 328p, whatever comes standard with the Arduino Uno. And you can use Arduino Pro Mini, you can use whatever. I just like this one because then when you're done programming the chip, you can just pry it off. And if you want to use it with a controller or plan it inside the controller, you just have this one chip. You also need a crystal, I guess, but plus one chip is like $4 maybe, and then the crystal's like 15 cents. So I mean, for the Bluetooth module, chip and crystal, I mean, that's really all you need other than a power source to put inside the controller, and you can make a pretty cheap wireless Bluetooth controller. Okay, so what I have set up here is a little whiteboard discussion of the logic that we're going to attempt to replicate within the Arduino. And basically that's the exact logic that Super Nintendo console employs with the controller. Basically we're just going to take that same logic, put it in the Arduino microcontroller, and as far as the controller knows, it's still interacting with the Super Nintendo console. And basically how this logic works is, so here's the controller and here's the end of the controller. You have a rounded edge and a flat edge. The pin closest to the flat edge we'll call pin 1. The pin closest to the rounded edge we'll call pin 7. Pin 1 is plus 5 volts, pin 7 is ground. Pins 5 and 6 we're not even going to worry about. They actually don't even have wires hooked up to them from within the controller, so we're not even going to worry about those. Pin 2 is clock, pin 3 is latch, pin 4 is data. Those are the 3 wires or pins that we are concerned with, because that's how all the data is transmitted and how we can grab the data from the controller. So basically what the CPU inside the Super Nintendo console does is every 16.67 milliseconds, which is about 60 hertz frequency, it's going to send out a 12 microsecond pulse. So you could say kind of it's dead, and then every 16.67 milliseconds you get this little pulse on the latch line. And it's about 12 microseconds. So at this moment, it sends this pulse up into the controller latch line, and the integrated circuits inside the controller then know, okay, we need to latch the current state of all our buttons together and prepare it to be shipped out the data line. The only thing it needs from here is a rate at which to ship it out the data line. And the CPU inside the Super Nintendo console also is going to supply that through the clock line. And what it's going to do there is, I think it's about 6 microseconds after the fall of the latch line, you have this clock line. So there'll be a little bit of a delay here, but you have this clock line, and it's going to do 16 clock pulses. It's about a 50% duty cycle and about 12 microseconds each. So you're going to have these clock pulses. And basically the logic here is, on every rising edge of the clock, the controller is going to shift out 1 bit of data. So this is going to be the controller shift for 1 bit of data. And on every falling edge, the CPU inside the Super Nintendo console is going to sample. And it's going to do this for 16 bits of data, or 16 clock cycles. and that'll give it 2 bytes of data, which represent every button inside the controller, current state of every button inside the controller. And it's just going to continue to do this whole thing every 16.67 milliseconds. So what we want to do is try to capture all this logic that the CPU inside the Super Nintendo is using, and we're just going to hook these same 3 lines up to an Arduino microcontroller that is doing the exact same thing or something very similar to capture the data from the controller. And basically you have these 2 bytes of data that are getting shipped out, and each bit in these 2 bytes corresponds with 1 button. So I wrote down, just for the first 2 bits, for example, the first bit is for the B button, and if it's 0, it's being pressed. If it's 1, it's not being pressed. The second bit's for the Y button. If it's 0, it's being pressed. If it's 1, it's not being pressed. So you end up with, say, both B and Y are currently being pressed. Then the 2 bytes of data that the Super Nintendo console receives will look something like this. You'll have 0 for B, 0 for Y, and then 1 on through to the rest of them. So you have the 2 bytes or 16 bits. And I think it's the last 4 bits in these 2 bytes, they don't even represent anything, because you don't have 16 buttons. So yeah, that's the basic logic behind the controller, and what we're going to do is we're just going to reroute these lines. Instead of going to a Super Nintendo console, it's going to go to the Arduino, which I think is something like the symbol for Arduino. But okay, so what I have here, I just wanted to show real quick, is the PCB from a Super Nintendo controller. It's one of the originals. And you can see I've detached, this cord was plugged in here, which goes out to the Super Nintendo console. And the old ones is nice because you can just yank this thing off and you have all pin access. On the newer, cheaper versions, you actually have to desolder the pins if you want to do something like this. But yeah, this is just to show you that there are 5 lines here, like I discussed in the whiteboard video. I think white's voltage, brown is ground, and then latch, clock, and data in between. So yeah, we're just going to attempt to basically hijack these ports from the integrated circuits that are located on the PCB and reroute them to the Arduino and specific pins on the Arduino. So yeah, so we just need to basically configure the Bluetooth module, program the Arduino with the source code, and then install an app on our Android device, and we should be pretty much good to go. Okay, so here we have our setup for programming the Bluetooth module. I know that there's probably better ways out there to do this. This is just my personal setup, and I know it works because I've done it multiple times. And basically, what I'm doing is just setting up a hardware connection from my computer to the Bluetooth module. And unfortunately, with these cheaper MD-Fly Bluetooth modules, which they're only like $13 compared to I think 35 or 40 for the Blue Smurf on SparkFun, on SparkFun's website, you have to actually set up a hardware connection because it won't let you program the Bluetooth module from a device that it's paired with, which means you can't do it via a Bluetooth connection. So if you have like a MacBook, which is what I did for my Blue Smurf, I just set up a Bluetooth connection, and that was made a virtual COM port from there, and then I could transmit the commands to the Blue Smurf. On this one, on the other hand, you have to actually make sure your Bluetooth module isn't paired to the device or the computer you want to program it. And that's the reason you have to go through all this, is because if you want to use this chip with an Android device or a phone, it needs to be set at a different baud rate. By default, it's set at 9800. I think it's 9800. And what you need it set at is 57.6K or kilobaud. So you have to go through this procedure to get it programmed correctly. Plus, once you get it going, you can like change the name of the Bluetooth module and all sorts of other stuff. Change the pin and the passcode that you want to pair with, and there's all sorts of kind of neat stuff you can do. So yeah, for the setup here, pretty simple. You can pretty much ignore this. It's just an old Almax development board I had from an embedded systems class. all I'm using really is this adapter, which is USB to serial, and this Max 232 chip right here. So basically I'm just plugging this into my desktop, and then here I've got, you can see receive and transmit. Receive is blue, transmit's green, and you just want to make sure they're connected to the opposite on the Max 232 chip. So for instance, blue is connected to receive here, and it's going to be connected to transmit on the Max 232 chip. And this is pretty much how it is for any serial RS-232 protocol or Bluetooth protocol for that matter. And then here I just have my Arduino. I'm going to plug it in, and it's just going to be powering the device, the Bluetooth module. So yeah, now I'll go ahead and get it hooked up and then show you how to program from the terminal. Unfortunately, it's only on a Windows PC right now. I tried pretty hard to get it working on my Mac, but there's just all sorts of driver issues. I'm sure someone out there who's smarter than I am could get it figured out. I did get it working on the Blue Smurf module I originally had via Mac, but this one I just couldn't get figured out. But I'll show the Windows version, so we'll go ahead and do that. Okay, so here I am at my desktop, and we're going to actually try to program the Bluetooth module now. You can see I have that same setup, only now it's on top of my desktop and everything's plugged in. Got my adapter plugged into a USB port on my desktop. And right when you plug it in, it should have a little window that pops up off your startup bar, or your toolbar, saying driver successfully installed, virtual COM port setup, or something like that, and it'll say COM4 or whichever port it has been assigned. And I think that depends on which USB port you plug it into on your desktop. I think if I keep using this USB port, it'll keep being COM4, which it currently is. I'm not positive on that, but I'm pretty sure that's right. And then, yeah, so we'll look at the resource to use here is the MDFly website, which I used to buy the Bluetooth module. You can see this is actually the version without the breakout board. You can buy one with it. I think it's $13, whereas this one's $9.95. This one will work just as well. You're just gonna have to actually solder the headers on yourself if you want to set up like mine, where I can just plug it in, not have to solder anything. At least for a demo purpose, that's nice. The actual controller I built, I had to solder one of these little chips in. But the feature set here, it just tells you coverage up to 30 feet, default baud rate. I think I said 9800 earlier, it's actually 9600. 8N1 you don't need to worry about. In terms of programming it, it's going to stay the same. I think it's just no parity, 1 stop bit, 8, I can't remember what 8 stands for, control bits or something. Pair code 1234, power input 3.3 volts. And then down here we have our documents. Datasheet you can look at, it'll tell you which specific port here, like which receive, what's transmit, and everything else. If you buy the one with the breakout board, you don't need to worry about that. AT command set we do want to look at. I have it open, I think, so let's see. This just tells you, okay, if I send AT, it should return OK. That's from the terminal once it's plugged in. That's just the check to make sure the connection is set up correctly. We'll do that once we get going. Other than that, this is the most important one, or the one we're most concerned with. We want to change the baud rate. So AT plus baud 1, that just means change baud rate to 1200 because 1 down here refers to 1200. And what we want to do is change it to 57.6K. So we're going to do AT plus baud 7. And down here you also have, if you want to change the name of the Bluetooth module, so when it shows up on other devices, it's kind of cool. I don't know. I think I changed mine to like Blue RKD or something for this one, and it's really easy to do. You can change the pin if you don't want it to be that default 1, 2, 3, 4, and then it gives you this little note down here, which I think I mentioned earlier. Will not accept an AT command when it is paired. So it recommends using a USB to TTL or USB to TTL converter module. Basically like what I've set up here, but you can actually buy one specifically. I mean, you don't have to deal with the Max 232 chip like I am and all that, but so yeah, this is the command set. We'll go back to here, and it does recommend a terminal software, and that's what I'm going to use. I personally don't like it. It's only a trial. It's kind of limited. I couldn't get the ASCII return to work correctly. I'll show you that. But the important thing is the Bluetooth module is connected, and when I open up this terminal software, which to tell you it's a trial, and this is just the 3 files it'll give you in like a .rar format. I just extract all 3 to my desktop. I think these 2 are just initialization files. It'll give you an error if you don't have them in the same directory when you try to run the exe. So we'll go ahead and run it, and I think when you initially open yours up, it'll be like this. Transmit hex, receive hex. We want it in an ASCII. Transmit ASCII, receive ASCII. And then, so yeah, I've got COM port 4. My baud rate though, at least it should be 9600, and that's what the default will be for this Bluetooth module. So that's what you're going to initially want. And then, like I said before, no parity, 8 data bits, 1 stop bit. So all good there. And now it should be ready to go. You can see down here it says COM 4. I think that's just the time of amount connection. So if I type AT, transmit, there. So it did, and okay, this is where it gets weird. E9. It's supposed to return OK. And I'm pretty sure E9 isn't hex for K. So I don't know what's going on there. But as long as you get a receive message back, you can then test to make sure that it programmed correctly. So for example, if I do, what do I want? AT, and then plus baud 7. So we got AT plus baud 7. This should change the baud rate from 9600 to 57.6K. And there I got another weird encrypted return message. But I can test to make sure it's working, and to do that I'll just change the baud rate to 57.6K, open the connection, and now if I send AT and I get a return message, I know that it did change the baud rate correctly. Otherwise I wouldn't have gotten a return message because the timing wouldn't have been correct. And then here you can also do AT plus name lowercase, and it'll change the name, give you another weird return ASCII. So if anybody knows what's going on with the return here, I mean, I could sit down and figure it out probably, but it works, and that's all I care about. Or if anybody knows a better terminal software, I'd be happy to hear it. But yeah, so now we've got the Bluetooth module set to 57.6K, and it is ready to be paired with the Arduino and an Android device. Basically what I have here is the Arduino IDE open, and this is where I write the code that gets programmed into the Arduino microcontroller. And you can see right off the bat here I have an include meetandroid.h. So you're going to need to, if you want to use this code, you're going to have to import the meetandroid library. And let me try to flip. You'll get that from this Arduino website, which I don't even know why this exists, but it's awesome. I'm glad they went through the trouble of making it. You'll need the Arduino Android application to put on your phone. You also need the Meet Android Arduino library. When you download this, it will just give you a Meet Android folder, and you're just going to put that in wherever you're. When you set up your Arduino IDE, it'll say here's your library, your default location. Mine was Documents on my MacBook. So in Documents I made a Libraries folder. It's like all lowercase. Put the Meet Android folder in there, and then restarted the Arduino IDE. And I went to, you can just go to Sketch, Import Library, and then under Contributed you see Meet Android appear. So then you just do that, and then it'll automatically, I think, put this #include meetandroid.h in there. So yeah, that's how you handle that. And if you can actually look at the library, it's pretty readable. The read and write methods for the serial input-output. It's just very helpful because then you don't even have to worry about it. You can just use their library. And in the code right here, you'll see I have these first 3 lines. This just refers to, okay, my latch 5, clock 6, data 7, and a controller data with an array of 16 to store the data for 16 clock cycles. This basically means 5, that's going to be the pin on my Arduino microcontroller that the latch line is going to be referred to, and 6 for clock is going to be the pin on the Arduino clock line, and 7 for the data. And I have this initial setup method here that's just going to set the baud rate to 57.6K, and then here's where it sets up my pins. Obviously, like I discussed on the whiteboard, latch and clock are both going to be output pins, because it's going to be simulating the Super Nintendo console, and it's going to be sending the latch output and clock output to the controller itself, whereas the data is going to be an input line. And here I'm just to initialize, I'm just going to set them both high. And then I have this read data method, which we'll get back to. This is the main loop. And most Arduino apps you write, you're going to have a main loop, and it's just going to continue executing this loop. And the first call it makes is read data, which is this method here. And basically all this is the exact same logic we discussed on the whiteboard. It's just written in Arduino code. You can look at it, and it's pretty easy to understand. Just for each clock cycle, I'm, setting the clock and data line clock and latch line accordingly, so that I can pull in the data. And then I have that controller data array, which I'm just reading the bits into, and then I'll end up with these 2 bytes of data in the controller data array. And then I just have a little button reference here for myself when I was writing the code. I can look at it. And in the main loop, you can do this more elegantly. I just wanted a nice comma-separated array of characters as an output, so that when I was writing my Android code for my custom app for the emulators, I could just say, okay, I know these specific characters, which buttons they reference, and then they're comma-separated, so I can see if multiple buttons are being pressed, or if no buttons are being pressed at all. It's just going to be an empty character array. So yeah, then it just goes through and says, basically, if controller data 0, which we know from the whiteboard is the B button, if it is equal to 0, then we know it's being pressed. And basically all this is doing is checking if the array is currently empty. If it's not empty, which at this point I guess it would always be empty, I would think, then we're going to append a comma to whatever is currently in there. But since it is empty, it's going to append J. And I know that it's weird that J is B, but when I was doing this, I just set up my own button or character correlation for each button. But yeah, it's just going to go ahead and do this for, yeah, you can see all the way to controller data 11, so 12 bits, and then the last 4 don't matter. And then it's just going to use I guess first it's going to convert, or it's going to use out.toCharacter array. That's why I've also been collecting the length as I go. And then you just need to send the length of the array, and then the out data itself, which is just going to be basically the character I've been building. It's going to use meetAndroid.send, send out that data, and then I have this delay of 16 here. It's just 16 milliseconds, basically like the Super Nintendo controller does itself. You don't actually need that, I don't think. You can make it less. I just wanted to stick as close to the Super Nintendo controller or console as possible. I don't know. But yeah, that's pretty much it in terms of the Arduino. Okay, so this is something I wasn't originally going to show, but I realize not everybody's familiar with the Android or Arduino and the uploading process and everything. Basically, all you need to know is here I have my Arduino board. It's connected via USB to my MacBook, and in here I have the sketch for the SNES code. And let's see. So, I guess important things to know. Board, make sure you have the right board selected. Mine's the Uno. So that's all good. Serial port, TTY USB mode. That's for my particular connection, which is this cable here going into that port. And then once that's all selected, you can compile the code. So you run verify. You'll see it's compiling. Done compiling, no errors, that's good. Then upload, I just hit this little upload button here. It's gonna say uploading and uploading complete. And you'll see here, while it's uploading, this transmit and receive little blinkers here start going kind of crazy. Another important thing to know is if you have everything hooked up, like say something in the transmit receive lines here, I don't think it'll program correctly. I know that's that way with the Pro Mini anyway. I haven't really messed with it on the Uno. Just good practice though is when you're programming a specific code in, maybe have a lot of the stuff unplugged. At least if you encounter any errors. Best practice is just unplug everything and then just you have the programmer, the USB thing plugged in. So yeah, that's pretty much all there is to programming the Arduino from a sketch in the IDE. Okay, so now that we have the Bluetooth module configured and the Arduino microcontroller programmed, we're ready to hook everything together, and pretty much the hardware side of this project will be complete. So yeah, we're just going to, basically I'm just using these wires because this is a very temporary thing on my part. I'm just going to end up taking it apart again. But you can, you know, like I said earlier, you can solder everything together in a much smaller form factor. But these things are great just for these quick projects. Just pair, they're like female-female or male-male headers, and then I can make it female-male. I have a set of wires here. And so yeah, for like a really quick project, it's great. But anyway, I've got two here. I like using red for the voltage line, black for ground. I usually use green receive, blue transmit from the Bluetooth module. Obviously they're going to be opposite on the other end. And then here I just have a bunch of wires crammed in here pretty much so that I can hook them up to the ports on the Arduino. And like I discussed earlier, so this is just going to go to ground. This pin 1 here is going to go to plus 5 volts, although it can be powered off 3.3 volts. And then pin 2 is clock, which is, according to my Arduino code, 6, pin 6 on the Arduino. So this is going to go to 6. Pin 3 of the controller is the latch, which is going to go to pin 5, I believe, on the Arduino. And pin 4 would be the data, which is going to go to pin 7 on the Arduino. So I'm just going to hook up all these to 5, 6, 7 voltage ground. And then I've got the base 2 pins here. Let's see if I can get the camera to focus, are receive and transmit. And those are going to go directly to the opposite corresponding receive transmit on the Bluetooth module. And also we've got plus 5 volts and ground on here, which is going to go to plus 5 volts and ground. And this can also run off 3.3 volts. So yeah, I'm going to go ahead and connect all this together like I just explained, and then we'll start sending data to the Android device. Okay, so what I'm going to show now is, now that I have it all set up like I discussed before, you can see everything is connected, and then the Arduino is connected to Bluetooth. And we got the controller right here, and here I have the Arduino application that I mentioned earlier when we were at that Arduino website. So you just download that APK and install it, and then you're also going to have to, once you have your Bluetooth running, you're going to want to pair it with your Android device. I already did that, it's already paired. So then when I open up the Arduino application, you can just do add Bluetooth device, select your paired device, mine's called Blue RKD, and then it appears here and you're ready to go in terms of connecting. So I'm going to go ahead and hit connect. You'll see it's connecting. That went green, and then this went solid, and it told me that it was connected. So then if I go to monitoring, right now monitoring's disabled. I'll enable it, and you'll just see it says Arduino says, and then this is stupid. I shouldn't have it continually pulling empty. It should only do it when data is being sent. So I don't know if someone out there wants to fix that code in the Arduino, feel free. But basically, press up, and you'll see. Let's see if I can get it to focus the character. That's the characters and if you do multiple buttons, for instance, both of these, I get that nice comma separated list. And yeah, so then any button I press, the corresponding character appears within the Arduino application. And that's pretty much the huge part of it, because you're getting data then from the controller as soon as the button's pressed to your Android device. In this case, it's an HP touchpad I put ice cream sandwich on. And then from there, we have I made the Easy Mode application. I don't know, it's just an application I made that actually one of my friends who worked on this project with me initially wrote a lot of the code for it. And then I went back and kind of refined it. As you can see, it's still pretty ugly in terms of it doesn't know it's on a tablet, so it's huge. But basically, let me reset the default device. You can write an application. This is just using creating a generic input method. If you go to the Google SDK website, you'll see they have, I think it's called SampleSoft Keyboard. We basically took that application and then got into the code and rewrote it so that it also used the Arduino applications, like an interface to the Arduino application, so that anytime one of these button presses got recognized, it would check which button got pressed, and then once you set your Android device to be in that input method, that specific input method, it would simulate a button, like a key press, basically. For instance, I guess I should say input method settings. Go here, and then we have, see, Easy Mode appears because that's what the application created within the device. And if I can enable it, and then when I go to change input method, it will be available here, and I can select it. And then we have button mappings here. That's just to map a button here to a specific key press. And I'm not going to go through, mainly because I don't really remember exactly all the Java code in the Android application. If somebody out there wants the APK file, I'll be happy to send it to them if they just want to run it. I'll try to actually provide a link to it somehow, so you can just get it, and then once you have Arduino installed on your device, you should be able to you're good to go. You can start playing games. Yeah, and that's really the fun part, and that's what I'll show next. Okay, so now for the fun part, we're actually going to play a game. So you can see I have it set up before, like I did before. Here's my touchpad. If you have the Easy Mode application installed, you don't even have to mess with the Arduino app. You just need it installed on the device. This Easy Mode application will make a call to it though and set up your connection. I just showed it before so you could see how the data was being received. But so yeah, default device, that's Blue Arcady, that's the one I just made today. Input method settings, this is where we're going to want to go ahead and enable the Easy Mode. Change input method, we'll go ahead and use that. And then you can see it's connecting, active connections, this one's solid blue, we know it's connected. Then button mappings, they should already be set to the correct values, I think. I mean, if you want to set them, it's pretty simple, you just up, so I'm going to hit up on here for the default, for the hardware key, and then it sets it. That's pretty much how it works. Okay, so now we're going to go to the emulator. For this, I recommend SNES 9X EX. It seems to work the best. Some of them have trouble with diagonal movements and stuff. So here I have a game of Donkey Kong already going. It's paused. I'll unpause it. You can see up, down, moving on the rope. This is very difficult to play one-handed, so I won't do much of it, but you can see pause, that all works. What is jump? Yeah, so and then I'll jump. I mean, there's videos out there of me playing like before, so let's see, I can switch characters. So yeah, I mean, the controller I just made, and I think the video is about half an hour long now, but works with my HP touchpad here, which is running Ice Cream Sandwich, and as far as I know it works on all the lower versions of Android, down all the way to I think 2.2 is the lowest I've tested it on. So that's the end of the tutorial. Thanks for watching. Please feel free to leave a comment or email me with any feedback or questions you might have. I'm sure there are a few or something I didn't go over very well, or maybe went over incorrectly, so I'd like to know any feedback. But yeah, thanks for watching.